Hello. Okay. Thanks for the kind introduction. Good afternoon, everyone. I'm Kaifu from AIKO Solo. Good to see you again on this fantastic BC workshop and talk about the BC technology. So 2025 is almost over, and this year is still very tough. But fortunately, the BC technology and the BC community become stronger, and the BC capacity is approaching to 700 gigawatt, so which is a very great news to us. This year, we review our R&D activities and also some innovative technology. So today, I would like to share with you some of them. My report includes 3 sections. First section is the reason why we choose BC technology for mass production. And then in the second part, I will introduce our innovative ABC technologies. I will spend most of my time in this section. And then in the last section, I will briefly introduce AIKO's technology roadmap. Okay, let's go. So why does AIKO own BC? 2025 have witnessed the fast growth of BC technology. Here I will not introduce a lot on the difference between each technologies. So I think everyone here has the answer in your mind, and also it's the reason why we gather here together again. There are mainly 3 types of BC technology: ABC, HBC, and HTBC. In 2025, HTBC solar cells attract more attention, but due to it involves the amorphous silicon deposition, so it is less cost-effective. Maybe someone will argue that the BC technology is promising, but it is very challenging and a very high cost. I would say the pessimists are always right, but the optimists keep moving forward. So AIKO is willing to do the tough but correct things. Here I will not repeat the development history of BC. I just want to emphasize the Purdue University's and the Professor Swan's and Lambert's contribution on the first concept of interdigitation BC technology and the first device. From that time on, a lot of companies devote themselves on the BC technologies industrialization, including SunPower, AIKO, LONGi, SPIC, Futurasan, and Maxim. AIKO started the BC R&D nearly 10 years ago, and we are very glad to achieve the gigawatt level mass production today. So at the initial stage of the mass production, there were a lot of issues present, like such as the low mass production efficiency, the low yield, low capacity, and also the expensive consumption cost, and no enough module reliability. So AIKO aims to solve this issue and achieve the gigawatt level mass production. The development technology mainly aims at the passivating content, performance, promotion, and the implementation, and the PM patterning design, and also the module reliability improvement. Due to the limited time, so I will not introduce all of them. I will just introduce several important technologies to you. So in traditional technology, the P and N region are formed in the same step by forming the same ternary layer and diffusing the phosphors and the borons from the PSG and the BSG. But due to the different diffusion coefficiency of the dopants, so one-step method cannot achieve the best performance of P and N passivating contacts at the same time. So here we study the tunnel layer thickness, pinhole properties, and the in-diffusion doping layers influence on the passivating contact performance. The pinhole conduction and the tunneling conduction in both regions are well designed and balanced. So finally, we can get the best performance for P and N region, which is a very solid foundation for VOC above 750 millivolt. As we have known what the best structure should be, we have to know how to make it let be. So in the traditional two-step method, the photolithography is used, which is expensive, low yield, low capacity, and during the process, pollution will be introduced during the wet chemical process. AIKO develops the so-called separate tech. So the PSG and BSG formed during the thermal process act as the self-mask. And the diffuse the doping, the P-type contact, P contact which systematically to study the LPCVD, laser patterning, and the wet chemical process. By synergistically and optimize the three process, we are able to achieve the best performance for P and N type region simultaneously. So if you still remember, the IBC solar cells is usually quite small, in 125 millimeter by 125 millimeter. It is due to the PM design. The pad and the boost bar are located at the edge. So the fingers have to cross quite along from the one side to the other side. So there is the micro clock at the edge during the welding process and also during the active application. The very long carrier transport distance also leads to the lateral transport loss. So the launch wafer is not feasible in such design. So we innovated to move the pads into the inner place and also apply the multiple bus bar design. So in such design, we can make the carrier transport distance shorter, so the launch wafer can be perfectly adapted. And also the mechanical load leading reliability issue is solved. At the initial stage of the MBB technology development, the fingers interact at the boost bar of the opposite polarity, which means the unit cells are isolated, which will lead to the ununiform EL and the low CTM. We solve this issue by connecting the fingers to the adjacent unit cells. So we are able to make the cell perform quite well, and you can see the yellow shows much uniform, and higher power gain and CTM gain by 0.33% are obtained. Here I would like to introduce something on the anti-hotspot technology. So as the cell size and the module power become larger, the firing risk also becomes increasingly important. the traditional bypass diode design turns out to be not suitable, not enough suitable to the firing risk. And AIKO designed the ternary diode structure based on the BC's interdigitation characteristic. The region under the shaded L with such structure will be short-circuited, so it will not work as a load and not to hit the cells. We carefully set up the amount and the distribution of the structure, so to balance the anti-hotspot function and the leakage. So you can see an image of the structure here. The module with such design shows much lower hotspot temperature and higher tolerance to the shade L. Usually, the module with without such structure will lose one insert power if one cell shaded in one string. But for the module with such design, the shade cell amount can reach to 3 to 4. According to the test report from TUV Note, the maximum hotspot temperature in the ABC module under shaded is below 100 centigrade, and AIKO received the world's first certificate on shading resistance of Class A. So for the BC solar cells, bending is a common issue. Bending happens since both of the positive and the negative electron locates at the real site, and also due to the different expansion coefficient between the solder strip and the wafer. So during the welding process, the heating and the cooling will cause expansion and the shrink of the solder strip. So it leads to the bending. And bending induced micro cracks and instability is a common issue. To solve these problems, we apply the multi-polysilicon stack under the pads, and the pad distance is also carefully designed, taking the bending compensation into consideration. AIKO also self-developed the world's first automatic welding equipment. In this equipment, the welding platform is slightly curved, and also the strip is in hollow design to release the stress during the welding process. Another pioneering innovation from AIKO is the full-screen module. Traditional technology by folding the welding tab will lead to the micro crack on cell edge. And another 3 millimeter extra tabbing rainbow is required. So we hide the post rainbow at the real site. By this design, we can obtain 1.8% gain of the active L and 1.5 gain of the power. So due to so much effort and R&D investment, AIKO built the core competence with patents leadership. Till now, we have over 1,800 patents, and 700 patents have been authorized. Most of the patents are located at the topics of cells and modules. We also have a lot of patents on the equipment since we did a lot of work on the mass production. And the number of the ABC patents application increased rapidly. We expect 2,600 patents next year. So AIKO's module has ranked the top 1 on Taiwan News list for 33 months And AIKO's module also have been listed as the most efficient residential solar panels by Clean Energy Reviews. Exciting news to you is that we now have reached the ABC module efficiency to 25.1%. And now we have delivered such high efficiency modules to our customers. AIKO believes BC technology is the must-have to reach the limiting efficiency of single-junction solar cells. So this slide shows AIKO's roadmap on the cost, cell efficiency, and the module power. Now we are approaching 680 watt, and we are also targeting at 700 and 720 watt by 2026 and 2027 respectively. Look ahead to further exploit the efficiency of BC technology. The photon multiplication and the photon recycling technology will be attractive. And once the stability issue of perovskite is solved, we think the tandem technology, especially the BC-based 3T tandem, will be feasible. My colleague Christian Peter from AIKO Solar Lab Europe will give us a presentation on this topic later in this afternoon. So in a much more distant future, technology like the upper convention, multi-junctions, and the interband solar cells are also worth to be explored. Currently, AIKO is collaborating with Dr. Zhang from Martin Green's team on the photon multiplication project. Dr. Zhang just gave us a very interesting topic on very interesting project presentation on this topic. With this, I would like to thank you all for your attention. So let's look forward even brighter of BC.